Hey guys, welcome to the start of a new topic. We're talking in this topic about quadratic equations, and I'm going to introduce a lot of ideas in this first video, and we're going to slowly work our way through understanding how these quadratic equations work, and then over the course of this series, look at how we can apply the things we've learned from the previous series this year on quadratic expressions. Now, a lot of the ideas we learnt in quadratic expressions carry over to this topic. Now we're just applying that to actually solving equations with these quadratics. Now, just as a little recap, our quadratic expressions, we defined before in our previous topic that all of these are written in this particular form. Some coefficient in front of x squared, plus or minus another coefficient in front of x, and a constant at the end. And for quadratic equations, or quadratic expressions even, one particular thing with all of these is that our coefficient of a cannot equal 0. If a equals 0, that totally kills my x squared, and this ceases to be a quadratic. Remember, what we need for this to be a quadratic is this x squared over here. Now, my coefficients of b and c, pronumerals b and c, those can be 0, but this a here cannot be 0. If a is 0, our x squared gets killed because it's multiplying by 0, and this thing ceases to be a quadratic. Now, quadratic equations are very similar to this. In fact, they are almost identical, but all quadratic equations are in the form my ax squared still plus bx plus c equals 0. This is the form that we're going to be working through when we solve our quadratic equations. And this thing here is called standard form. This is what we call the standard form of quadratic equations. So anytime we want to solve a quadratic equation, we want to get everything on one side equaling to 0 on the right hand side. So let's do a couple of questions in which we actually practice writing these in standard form. We're not even going to be doing any solving of these, just getting them to standard form. So question 1, x squared equals 2x plus 7. I want to get everything grouped on the left-hand side along with my x squared. So what I'm going to do, I want to systematically move things to the left-hand side of my equal sign to balance the equation and get my quadratic in standard form. So to get this 2x on the left, I want to subtract 2x from both sides. So when I balance this out, I'm going to get, x squared minus 2x equals positive 7. And then finally, I'm going to get the 7 to my left-hand side. Because remember, I want 0 on this end of my equal sign. So I'm going to subtract 7 from both sides. Remember, what we do to one side, we have to do to the other. To get from 7 to 0, I'm going to minus 7. And then because my left and my right hand side are equal, what I do to one side, I have to do to the other. And now I wind up with x squared minus 2x minus 7 equals 0. Now I have my quadratic equation. I had a type of quadratic equation up here, but now I have it in standard form. All of my terms on one side, my expression on one side, equaling to 0 on the right-hand side. Alrighty. So, question 2. I have 2 outside of x squared minus 3x equals to 5. And I want to get this in this kind of form, right? I want all these coefficients in front of my terms separately. So for something like this kind of looks a bit messy. So I want to kind of kill these brackets here by expanding out. So when I expand, just a reminder, we want to multiply my outside term by all of my inside terms. So 2 times x squared gives me 2x squared. 2 multiplied by negative 3x gives me negative 6x. And I've now successfully expanded my brackets on the left-hand side, and my 5 stays the same over here. And now remember, in standard form, like the one we have here, I want everything on the left with a 0 on its own. So to get from 5 to 0, I'm going to subtract 5, and I'm going to do this to both sides of the equation. And finally, I wind up with 2x squared minus 6x minus 5 equals 0 on my right-hand side. I have this now in standard form, which you'll see later will allow me to actually solve this equation. Now, our final question in this section, I have 2x minus 7 equals minus 3x squared. Now, once again, I want everything on one side. So I have these already here. So I'm going to want to bring this term, negative 3x squared, over to my left-hand side. Now, to get this to 0, I have to plus by 3x squared. Because no matter what x squared is or what x is, adding 3x squared to negative 3x squared is going to give me 0. And I'm going to do that to both sides here. And I wind up with positive 3x squared plus 2x minus 7 equals to 0 on the right-hand side. So now we've covered the idea of writing things in standard form. Now the next part of the video, we are looking at testing for a solution. So you may remember when we did our regular equations way back when, to solve these equations and check that we had the right answer or the right solution to the equation, we would substitute the value of the pronumeral back into the equation to say whether it is or isn't a solution. Now, we're going to do the same thing for our quadratic equations here. And what we're going to do, I'm going to write an equation out here, a quadratic equation that is, and I want to check if x equals 2 is a solution. Now, remember, if something is a solution, when I sub it into my equation, it will make the equation true. So if I put in x equals 2, this side should equal to 0. If the left-hand side of the equal sign is the same as the thing to the right-hand side of the equal sign, then my value of my pronumeral is a solution to the equation. Remember, a solution to an equation is just a value that makes the equation true. So makes this side equal to this side. Okay, so looking at this, we are going to substitute x equals 2 in both of my x's here. So when I substitute that in, I get 2 squared plus 2 minus 6 equals to 0. Now 2 squared gives me 4 plus 2 minus 6. Now 4 plus 2 gives me 6 minus 6. Okay, and when I subtract 6 from 6, I get 0. So what I found here is that my right hand side equals my left hand side. So that means x equals 2 is a solution to this equation. It is a value that when I sub into here and here, it makes this equation statement, x squared plus x minus 6 equals 0, true. And we show that by seeing that when we sub it in, my left hand side is equal to my right hand side. Now, let's look at one more example from this section. And that is this equation here. I have 2x squared plus 5x minus 3 equals 0. And I want to check if x equals minus 4 is a solution. So once again, I'm going to substitute x equals minus 4 into here and here. So I have 2 times minus 4 squared. I've just written this in brackets to avoid confusion. You'll see why later. Plus 5 times minus 4 minus 3. And we want to see if my left-hand side equals to 0. Now here I have a negative number squared. So that means I have a negative 4 times negative 4. That's going to give me positive 16. So this means I'm doing 2 times 16 here. And then I'm adding to that 5 times negative 4. Now a positive number multiplying by a negative number gives me a negative number. So that's going to give me minus 20. And minus 3 equals 0. So if I simplify this, 2 times 16 gives me 32. Plus minus 20 is the same as writing minus 20 minus 3 equals 0. And when I do all of this, this gives me 9. Now does 9 equal 0? No. So the left-hand side does not equal the right-hand side. So x equals minus 4 is not a solution to this equation. And we can always check solutions from way back when we first looked at equations. We can check solutions by seeing if, when we put it back in, the left-hand side equals the right-hand side. Now in this case, it doesn't. All right, one more thing we're going to look at in this video, and this is a long introduction to quadratic equations, I realize that, but these are all important ideas that we're going to be building up on. So, one thing we are going to end with today is something called the null factor law. Now, it's got a fancy name, but the idea behind it isn't too difficult to grasp, hopefully. So, consider a product. So any product of numbers. Let's say a times b equals to 0. Now, the null factor law tells us that if the product of two numbers is 0, then either one or the other, or both, are 0. Because think about it. To get any product of 0, one of the numbers multiplying must be 0. You can't get 0 as a product any other way. If I do 6 times 2, these are both non-zero numbers. That gives me 12. The only way I can get my answer here being 0 is if I did, for example, 6 times 0 or 0 times 2. I need one of my numbers that are multiplying to be 0 in order to get 0 as a solution. Now think about all of my quadratic equations in standard form. They all equal to 0 on the right hand side. That's what standard form is. So in order to say that a solution is 0, either A or B, or both A and B, have to be 0. So I'm going to write that here just for a bit of a recap. So for this equation to be true, either A equals 0, B equals 0, or both are 0. Now this almost seems trivial because you're probably asking yourselves, well, of course, I know that the only way to get 0 as an answer is one of the numbers has to multiply by 0. But this idea is actually going to become really useful when we look at actual solutions for these equations and how we even approach solving these equations way into the future. But we're going to take this idea and apply it to some early forms of quadratic equations, or some factorized forms of these. So in the next few questions, we're going to use this null factor law. So for this first equation, I have x outside of x plus 2 equals 0. So in other words, x times x plus 2 equals 0. Now, we have a 0 on the right hand side. So it means we have two possibilities here. One of these expressions, either x or x plus 2, must be 0. That's the only way it's going to work because they're multiplying together to give me 0. So to solve this equation, we want to find the options for these two that are going to give me 0. So in other words, I'm still solving for x, but I'm considering the two factors, x as well as x plus 2. I'm considering both of those, and I'm saying that each of these have to be 0. So what's x going to be to make both of these orange and pink expressions to equal 0? So for this to be true, either x has to equal 0, because think about it, if I substitute 0 into here, so one of my solutions is going to be x equals 0. Why? Because it's multiplying by this expression. So my first term x can be a solution if it's 0, because substituting it in x equals 0 is going to give me 0 outside of 0 plus 2. Now, we want to see if that equals 0. See, I've just subbed in x equals 0 into here and here. I've just done that there. Now, this is saying 0 times 0 plus 2. Now 0 plus 2 gives me 2. So this is 0 times 2 equals 0. Now what does 0 times 2 give me? It gives me 0. 0 equals 0. This is a solution to the equation. So I've just taken this guy here to be 0. But now that's not the only option here. I can also have this term, if we think about these two from the example here with my null factor law. The first one I looked at was A. A can be 0, but B can be 0 as well. So this expression here can also, we can find a value for x that makes that 0, because we can multiply that by whatever other term and it'll still give me 0 as a solution. So another option is when x plus 2 equals 0, taking this entire expression to equal 0. Now if something plus 2 equals 0, I can find out what that something is by just solving the equation, and that gives me x equals minus 2 here. Now I can check this, right? Because just for this first example, I want to really give you a sense of how this null factor law works. And I know I'm saying a lot of zeros here, but hopefully this is giving you an idea of how we end up using the null factor law. So if x equals negative 2, so we're going to sub in x equals negative 2. So I have negative 2 outside of negative 2 plus 2 equals 0. That's just me subbing negative 2 into my equation up here. So this negative 2 I can leave alone, but it's multiplying here. And minus 2 plus 2 gives me 0. So I get minus 2 times this thing here becomes 0. And minus 2 times 0 gives me 0. And this is another solution to the equation. So when we use the null factor law, we're pretty much just finding what values are both of these x's going to be in order to make each part of this product 0. The same as this a times b equals 0. For this equation to be true, either my first thing multiplying, so this one on the left, can be 0, or b, my second one here, can be 0. And that's this whole term, this whole x plus 2. So we're going to do this with a couple of other examples here, just to really drive this idea home. Okay, so for question 2, we have x minus 1 and x plus 5 equals 0. Now, remember when we have these two things next to each other like this, a multiplication is implied. Now, there's two ways we can go about this. Remember, if we take this to be my A and this to be my B. Now, you don't have to write this in, but this is just to show you the null factor law that we did before. So remember, either this one can be 0 to make this equation true, or this expression can be 0 to make this equation true. So I'm going to go down two separate routes to get the answer. So either my first expression, x minus 1, is going to be 0, or my second expression, x plus 5, is going to be 0. Those two are both going to be solutions to my equation. Now, solving this equation, something minus 1 gives me 0. We can find that something by just doing this opposite operation. I'm adding 1 to both sides. So x equals 1 is a solution here. And my other one here, I have x plus 5 equals 0. I can find a solution to this equation by just subtracting 5 from each side, and I wind up with x equals minus 5 here. So these two are my solutions. Are my solutions. And you can try at home if you want. You can pause the video, try substituting x equals 1 and x equals 5 into this equation. So first, do 1, pop 1 in here, see if it gives you 0. Then the next time around, pop negative 5 into here and negative 5 into here, see what it gives you. And you will see in both cases, you will get the left-hand side equaling to 0. Which is a solution to the equation because it's the same as the right-hand side. It makes this equation true. Now, one more question to wrap up. This is a slightly harder one. By harder, I just mean we're going to do a couple more steps. But this thing here, 2x minus 1 and 5x plus 3 equals 0. Okay, now remember, by our null factor law, one expression, 2x minus 1, multiplied by another expression, 5x plus 3, it can only equal 0 if this whole expression is 0 or this whole expression is 0. So we can take our two different ways and find the two solutions to our equation. So my first one option is my first one can equal 0, or my second one can equal 0. All right, now to go about systematically solving this equation, we are going to just work our way through finding what x is going to be. So first, I can just add 1 to both sides. So 2x equals 1. And I can once again do the opposite. 2 here is multiplying by x, so I can divide both sides by 2. And I'm going to get x equals 1 divided by 2, or 1/2. And for my next one, I'm going to do the same thing. I'm just solving systematically. We've been doing a lot of this in previous topics, so if any of this is new, please go back and watch that. So I get 5x equals to minus 3, because I'm subtracting 3 from both sides to get back to my x. And I have 5 times x, so I'm going to do the opposite operation. I'm going to divide by 5. And I'm going to get that my x equals negative 3 on 5. So these are my two solutions to my equation. And you can have a go at this as well at home. So first, try x equals 1/2. Try putting that here and here and see if you get 0 on the left-hand side. Another thing you can do, you can take your x equals negative 3 over 5, substitute it into both of these x's, and then see if you get 0. Now, one of the big ideas that I'm hoping some of you have caught on to is that now that we're working with quadratics and this null factor law strategy, we looked at these questions, we had these two binomial products. So one thing we're going to be working with in this series is reducing things to binomial products, which allows us to use the null factor law. And we always had two solutions to my equation. Here and here, we had two solutions. We're going to talk about this a lot more in future videos and future series, but Right now, the main ideas I want to get you thinking about is this idea of a null factor law. How can we make each two elements that are multiplying by each other equal 0? How are we applying this to my binomial products here? And have a go at some of these questions, and also try substituting our solutions back in and see where you get to. But thank you so much for joining me. I know it was a long video, but we have a lot to get through with quadratic equations, so I will see you in the next video.